Hi, everybody. No agenda in the first few minutes. Feel free to introduce yourself either over voice and video or just say something in chat. Um, Anything you want, I suppose. But I think your experience level and where you are in your job hunt, if you are happily employed or looking for new work or looking to get into the industry, just let us know. I found um, people are in all sorts of different places in terms of experience and what they've picked up, how they got there. So I'm sure we'll have a diverse audience. Tom, does the screen share look okay? Is it clearly legible? Like if I type here, oh man, why is this? I don't want this down here on the side.
Looks good so far, I guess.
Great. Yeah. Yeah, don't be shy, everyone. I'll only get into the actual content, say on the hour or maybe a minute or two after. But okay, Tom, you can hear me. Chris cannot hear me. Lakia cannot hear me, unfortunately. Hmm. You can hear me now. Okay, good. I was considering rejoining, but okay. Yeah, at the bottom, next to the little microphone with the mute text under it, be sure to have the correct microphone and audio output selected. Interface looks a lot like Zoom, so should feel familiar. Someone want to share where they're at in their job search? If they're searching, are you guys currently working? Where's everybody at? Working remotely. All right. Thanks for sharing, Sammy. So what got your interest from this? What got your interest in this session? What were you? Are you actively interviewing? Are you passively interviewing? Looking to just skill up?
I actually made 2 years at my job this month, so I'm planning to start getting into the job market towards the end of the year. So this is me practicing my data structures and algorithms, but slowly getting in there.
Okay, cool. Yeah, it's definitely it can definitely be easier when you do have a proven track record, and 2 years certainly is enough tenure that you have proven yourself. Cool. Yeah, I'll get into my whole teaching methodology in a moment. Anybody else? Hi, Brian. Combinatorics, Tommy. I see Tommy's peeking at my browser tabs. And well, I do mention combinations and permutations in the event. So combinatorics is a mathematical concept that contains those two concepts and more. It's also possible that you have used combinatorics in the office and didn't notice. I have my own site, CoachMatt.io, where I create algorithms, and I'm building a whole platform to help people, to give people more tools to learn concepts and algorithms and interview better. And I didn't realize this until putting a lot of this stuff together, that anagrams, right? Like figuring out if two words are anagrams of each other, that's a permutations problem. It's is this one word another ordering of another word? So yeah, the whole idea of this talk is learning core concepts and then composing solutions based off of your previous understanding of the problem. So we do have 73 people queued up, and I'm not going to assume that we'll have that many people here today. We've got a good amount of people here, so thank you everyone for being on time. Yeah, I guess I'll get into it. So my name's Matt. I go by Coach Matt. I have seen pretty much every side of the interviewing process. I have worked as a hiring manager. I have hired people as an individual contributor, as a manager. I have interviewed at companies myself, of course. I've been accepted at Microsoft, Google, Facebook, other companies within Silicon Valley. I've been rejected. I have, of course, hired people myself and rejected many people. I have a lot of opinions about interview processes and what works well, but that's a bigger conversation. I've fired people. I've been fired myself. So yeah, just seen the full gamut over my my career, and I've been mentoring engineers throughout my 10 years of experience as well too. So it's something that I find myself really drawn to. And my whole approach is a concepts first understanding. Zach, I'm getting some feedback from, thank you, and welcome. In terms of how we're going to interact today, I think we're going to have too many people to have others come in and turn their mic on. But feel free to ask questions. Please do. If you do have questions, it's very, very likely that someone else has that same question or a similar question, or your question will inspire more thoughts in others. So please ask questions along the way. There's a lot of stuff that I want to cover. And yeah, I'll be happy if you can walk away from this and clearly identify the two concepts that we've laid out. So combinations and permutations. These are the two concepts in hand. So what I want to do is concisely define what these two concepts are. So there's two things we're going to be focusing on primarily. There's combinations and there are permutations. So a combination is essentially, could be thought of as a subset. So one collection is a combination of another collection if it has every element or fewer than the parent. Let me rearticulate that. So a combination is some subset of a collection. So you can take an array, and that array is a combination of itself, but you could also remove elements, and then that modified array will be a combination of the original array. Are there any questions about that? So I'll pull up my cheat sheet on combinations. So my definition that I've laid out previously: a combination is a selection of elements from a set where the order of the elements does not matter. So the selection, you can choose to include the element or not, right? So if you just have A, all the combinations are nothing or A and B, nothing, A or B, or A and B. Are there any questions about what a combination is? Another way to think about it is for each element, you get to decide whether or not that element is going to be in the combination. Okay. So combinations, right? We'll just call this a subset. Choose, and order does not matter. That's really important. Permutations is a little bit different. In permutations, order does matter. So if you have A, B, and C, all of the possible orderings of those values is going to be all of the permutations of that original array. And as you see, A, B, and C is a permutation of A, B, C. So these are similar, but not quite the same. Are there any questions on combinations or permutations? Because what I want to do next is go over a few problems and ask you all whether or not this relates to combinations or permutations. Don't be shy. I'll take a minute to prep the next section. All right, how many people do we have here? 1, 2, 3, 4, 5, 6. Okay, about 20 people. All right. So I do want to have engagement from you guys. So let's get some voting in a moment. Okay, so Jose asks, so the result of a filter operation can be called a combination of the source array, and the result of a sort operation can be called a permutation of the source array, right? Exactly, yeah. So that's a really great rearticulation using concepts that JavaScript engineers are going to be really familiar with. So the filtering and sorting exists across languages. But if you are to filter, say we have a source array, 1, 2, 3, and then I console.log array.filter x is greater than 1, let's say. Right, there's no way I can add values with this filter. This filter is only going to potentially filter values out. So yeah, Jose, that's a very concise articulation of that. I like that a lot. I might steal that. And then sorting is right with permutations. This is a specific ordering of a list of values Cool. Yeah. All right. So let's get into a few problems. I think we can. Okay. Well, first of all, let's get into some code before that. Let's figure out how to check if something is actually a combination of something else. So this is going to be in JavaScript. I'm not going to get too fancy with the JavaScript. So if JavaScript isn't your language of choice, hopefully you'll still feel at home. So if we want to figure out whether or not something is a combo, what we can basically do is we can count up each value within the original array and then make sure within the potential combination that there isn't a single value that appears more times than it does in the original array. So you have to imagine that the original array could have multiple values. So it could be 1, 1, 2. Of which 1, 2, 1 would be a combination, 1 would be a combination, and then naturally the empty array would be a combination as well. So right? Let's just count up everything into a map. Try to get through the coding really quickly because okay, so we'll add 1 if not counts dot has element counts dot set element 0. I'm not going to get too fancy with the JavaScript here. Counts dot get element no, set element counts dot get element plus 1, increasing 1. Right, so this is count up values in array, count down with values in combo, fail if count is less than 0. So for const element of combo, if not counts dot has element, return false, right? If it's not in the counts, then that means we haven't seen that element before at all. If counts dot get element equals 0, return false. We could simplify this, but I'm not going to get fancy with the JavaScript today. Counts dot set element counts dot get element -1, and then just return true at the end. So console.log is combination 1 2 1 2 1. Let's hopefully I didn't make any silly mistakes today. It looks like I did. Counts.set element 1. Element counts.get element +1. If the count does not have that, return false. If counts should iterate over array in line 14. Thank you. Yes. Putting and talking at the same time is very difficult. A good point on that actually in an interview process. So sidebar, while you're interviewing, thank you, Jose, by the way. If you feel the urge to talk through your process and code at the same time as a candidate in an interview process, don't, right? If you're following best practices, right? If you're writing a reasonable amount of code and testing your code along the way and writing good readable code, then you are communicating through your code, right? You don't have to talk and code at the same time. So really the priority in my mind is number 1, code if you know what to code. Number 2, talk or communicate. That could be communicating via pseudocode or a drawing or asking questions to the interviewer or talking. So trying to code and talk at the same time is really tricky, and I'm finding the right balance here in a session like this. So, okay, great. So this figures out if something is a combination of something else. We can do this really quick also just to make sure that empty array is a combination. Let's have a false case here. I'm getting audio from someone. Please make sure you are muted. This one should be false. What am I doing here? Console.
Line 21 should be going through the combo.
Great. Thank you for that. I do have code prepped over to the side, but yeah, okay. Great. So we have this is combination check. If we want to check whether or not something is a permutation, right? Another way we could do this is something very similar. We have this, we count up all the values in the original array and then count down with all the values in the other array. And what we want to make sure that everything matches up. So all of the counts should be within the map should be 0. So I'm going to try to not make any mistakes this time. So we'll say is permutation Combo is going to be renamed to permutation. Permutation. Right. So if it's not in there, return false. And then what we can do is also just decrement here. And then what we can do is for const count of counts dot values, just making sure that all the counts actually are 0. If count is not equal to 0, return false. And is permutation 1, 2, 3, 3, 2, 1. Let me know if anyone feels like we're going too fast. Hopefully we're not. So that's permutation. Great. Not aware of any silly mistakes that I've made so far. This next one should be false. True, false. Yeah. So that looks good. That's one way to do it. Another thing that you can do too is you could sort all the values within the array, squish it down into a string, and check if the strings are equal. So this is something that you can use if you can stringify things really quickly and safely. Right, so let's say we'll just call this A and B now. So A.sort, B.sort, and then something like return A.join. Let's pretend these are arrays of numbers, so we'll have to use a little delimiter here, right? Equals B.join. We want to avoid the case where something like 1, 1, which would look like 1, 1, the string 1, 1. We want to differentiate that between something like 11, which would then stringify to 11. So this is more expensive in terms of like the big O complexity, right? It's a lot less code. I think it's a lot easier to reason about. But yeah, so there's kind of two ways to check if something's a permutation. And if you understand what a permutation is, if you understand what a combination is, and you can also check both of those things yourself, then I'm happy. My job here is done. But we can, of course, take this a lot further. Now, what I'd like to do is go over some problems, and I want us to decide whether or not this is a combinations or a permutations problem. So let's go over, let's say, power set. So the power set is basically, this is a math thing. So if you have the values 1 and 2, what we want to do is we want to return an array that looks something like this. And we don't care about the order here. Right. So given these two values, we want to create an array that contains all of the subsets of the original array. Is this a combinations or a permutations problem? And just say in chat which one you think it is. Combinations, thank you. Yes, so we are live. Great. Combinations, okay. All on the same page so far. Yeah, I'll do one more and then we'll get into ones that are a little bit more tricky. Anagrams. So let's say this isn't palindrome, right? This is anagrams. So ABC is an anagram of CAB. So it's a reordering of these letters to make this. And you can have multiple letters. A foo is anagram of OFO. Reordering. Which one do we think this one is? Now the permutations. Thank you. Getting more engagement. Cool. Yeah, that's great. All right, so let's get into. So these are pretty basic. You're probably not going to see these in a real interview. Well, the power set one actually does get asked, but usually anagram problems are going to. It's going to be a larger problem that where you will a component of that will be checking whether or not words are anagrams of each other. So Sudoku validator, validating a Sudoku board. So a Sudoku board is basically a 9x9. Correct me if I'm wrong. A 9x9 grid where each cell has a number 1 through 9 or is blank. And what you want to do is you want to make sure that no number repeats across each row, column, or 3x3 cell. And the 3x3 cells don't overlap. It's 3. Yeah, it's 9 3x3 cells that compose of the entire Sudoku board. So maybe I can draw that for a moment. The Sudoku board is something like the drawing mode is busted, but hopefully that one makes sense too. So what about the Sudoku validator? Is that a combinations problem or a permutations problem? This one isn't quite so obvious. Well, so the cells are actually considered independently. So you have a cell is going to be 9 cells. Sorry, I'm conflating terminology. So let's maybe forget about the 3x3 cells and simplify the Sudoku problem. Let's just for now pretend a Sudoku board. You just need to verify that there's no repeating numbers in each row or each column. Okay, this is getting interesting. So let's dive a little bit into the Sudoku validator. The options that we have for a row or a column is, of course, the numbers between 1, 2, 3, 4, 5, 6, 7, 8, 9. And the only way that we can have a row or a column that is invalid is if that row or column, and for now we'll just assume that there's not going to be bogus values. We're not going to get like a number 10 or something. Okay. Someone's saying combinations. That's great. Yeah, so this is really the stuff that you have available to choose from, and you can't take anything more than this, right? So you can think of each row or column as being some subset where we don't really care about the order once again. So a good way to figure out if a good indicator of whether or not something is a combinations or a permutations problem is if the order matters. And for validating a Sudoku board, the order does not matter, right? So this is your parent set. Yeah. And you have to make sure that each row or each column is a subset. And I'm using the mathematical definition of a subset, where a subset A set is a subset of itself. If you want a smaller one, it has to be, that's called a proper subset. But yeah, this is all you can choose from, 1 through 9, and only once for each number. And you want to make sure each row, column, or little 3x3 region is a combination of this 1 through 9 collection. So yeah, validating a Sudoku board is a combinations problem. Awesome. Anagrams was, what do we say? Permutations. Okay. So that one tricked some people. That's cool. Hopefully we're things are sticking. So knapsack. This one might sound a little scary. These concepts or problems that just have one word where it's not necessarily self-evident what the problem is actually asking, and I think be intimidating, like knapsack, backtracking. But I have a definition here that I'm pretty happy with. Someone's saying fizzbuzz, right? Fizzbuzz does not. I don't see how fizzbuzz relates to one of these two concepts, but that made me laugh. Given a set of items, each with a weight and a value, determine, right? So there's more things at play. It's not just strictly, is this thing a permutation or is this thing a combination? But given a set of items, each with a weight, each with a value, determine which items to include in the collection such that the total weight is less than or equal to a given limit and the total value is as large as possible. So it's optimizing some selection of elements from an array, and that from a collection, and that collection, each item in that collection has some metadata about how heavy it is and how valuable it is. So what about knapsack? Is this a combinations or a permutations problem? Combinations, Victor says. Does anyone disagree, or do we all agree with Victor? This feels like asking for a subset combination. Yeah, subset, right? Great. Combination. Okay, awesome. Cool. You guys are catching on. This is great. I love it. Then let's go for 2 more hard ones. And I think we're going to have a good amount of time to actually do some code on a hard leak code problem. And yeah, we'll see what we have time for at the end. Okay, so this one has a little bit of domain knowledge. Brian, I'm assuming this is the Brian that I already know. You know this one already because we've worked on this together in one of our sessions. Chess 960. If you don't know about chess, don't worry about it too much. But chess 960 is a variant of chess where the pieces are randomly arranged and there's some additional criteria. Let's not worry about the additional criteria. Let's just assume for now that your row of pieces looks something like, originally it looks like, say, a rook, knight, bishop, queen, king, bishop, knight, rook. Specifics of those pieces don't matter too much. And basically we want to figure out, we want to compute all the possible arrangements of this row. Once again, there's some additional constraints. That's not relevant to the conversation right now. What about chess 960? Is this a combinations or a permutations problem? Permutations? You guys are quick. Seems like permutations. Okay, cool. So the Sudoku one is the only one that tripped up some people, and otherwise we've been nailing it. permutations. This is a permutations problem. Awesome. If you want to try these problems, I do have my own site. Let me just drop a link right here. You can find me. I've got a YouTube channel, I've got LinkedIn, and then the first 3 links go to my site, where I've got a chess 960 problem. But let's focus on a hard, I'm going to, do this kind of air quotes, hard leak code problem. So hopefully this, so when I read this, and admittedly I've been focusing on interview algorithms, I was a like head of content at a boot camp for a while. I've been helping candidates interview for quite some time, and the way that I teach is this concepts first methodology, where I feel that conventional solutions like leak code focus too much on algorithms without focusing on the concepts. And I think that when you learn the concepts and have that library, that language, you can more naturally recognize when what you already know can be leveraged and compose a solution with the concepts that you know. So we've really only been explicitly talking about combinations and permutations, but there are, of course, other concepts. So I invite everyone to suggest any other concepts that seem relevant to this 24 game. So the text might be a little bit small. Let me do my best job to explain, what this problem is actually getting at. So 24 game, you are given an array of 4 numbers. Let's say 8, 8, 8, 7, 1. What you want to do is figure out some arrangement of those numbers and some way to mathematically operate on those numbers, right? You have a plus operation that you can use. You can subtract, you can multiply, you can divide. So these 4 numbers, arrange them however you want, and then use whatever mathematical operator you want. And you want that mathematical expression to evaluate to 24. And what we want to do in this algorithm is we want to return true if and only if there is some arrangement. There is some arrangement of these numbers and use of these mathematical operators that resolves to 24. So a lot more moving pieces here, but this definitely leverages either combinations or permutations. So what about the leak code? 24 game. Does this feel like a combinations or a permutations problem? Zach says permutations. We'll wait for a couple other people to jump in. Feels like combinations, not all numbers may be used. Actually, thanks for elaborating on that, Tommy. You do need to use all of the 4 numbers that you are given. I did not specify that. I oversimplified the description. So, right. So one of the things we talked about, a good way to differentiate between, okay, Tommy changed his vote to permutation. Does order matter? Does it sound like order matters in this problem? So addition is commutative, right? Order doesn't matter when you're using addition, but it does matter when you use subtraction and multiplication. Well, not multiplication. Multiplication is also commutative. It does matter with subtraction and division. So yeah, this is permutations. And while you don't have to solve this with recursion, I think this problem makes a lot of sense with recursion. Any operator can be used more than once, yes. But I'm the permutation problem that I'm seeing is that each number has to be only used once. So it's some arrangement of the 4 numbers. So apologies if my oversimplification of the problem description wasn't clear, but it's hopefully a good portion of you guys understood what I was trying to convey. So can't use a number more than once. More specifically, you have to use every number once. So we want to arrange the numbers in some order and then also choose some mathematical operator. So the mathematical operator isn't really relating to the combinations or permutations. It's which permutation of these four numbers do we need? And then we glue it together with the mathematical operator. So yeah, like basically for this problem, this is a brute force problem. This isn't really fancy. Judge point 24, you want to find out, is there some arrangement of these four numbers and some selection of these mathematical operators. I suppose it actually could be a combinations problem too, where maybe you have like, four of these little plus operators to choose from and four of these minus, and 1, 2, 3, 4 of these and four of these. That's not how I thought about it, but actually, just now I'm seeing it that way too. So it's really some permutation of digits and operators, or actually, it's not so much that, because the order of the operators does matter. So, hopefully that wasn't too confusing. Okay, so basically, pseudocode for this. What I'm thinking is we want to, for each permutation of cards, for each operator, it's a good way to pseudocode this. So I want to tackle this recursively, and I want to break this problem down. So if we have four numbers, let's say just simplify it to 1, 2, 3, 4. I don't think that this resolves to 24. Actually, it does. You just multiply everything. So 6 times 4, 12, 24. Okay. So when I solve a problem recursively, I like to first think of the signature. A little super quick crash course in solving problems recursively. This is where it gets a little, hopefully everyone can follow along. If you feel lost, don't worry about it too much. But yeah. First I get the signature, then I get the base case. And then step 3, I recurse. So what I want to do is I want to recursively break these cards down, and I want to shrink this expression down. So if I have 1, 2, 3, 4, and I decide to use the times operator, then I want to multiply the first two numbers, and I want to have 2, 3, 4. And if I use times again, I want to, the multiplication again, I want to have 6, 4. And if I use the multiplication again, then I want to have 24. So basically, we're going to take the first two numbers from the array, perform whichever operation we want to use, and then create a new array with that. So do we need any additional arguments for this judge point 24? I don't think we do. I'm happy with this function signature. So let's just do the base case. We're going to be always given an array of 4 numbers. So let's just say if cards at length equals 24, equals 1, if we just have one number left, we have found a solution if that number is 24. So return cards 0 equals 24. That's your base case. Otherwise, we want to, for each permutation of cards, for each operator, do the math. It'll be, operate on the first two terms and recurse. So let's drop in our permutation. Oh, I didn't go over generating permutations. So I skipped that. But naturally, if you're really familiar with the concept of combinations and permutations, you'll be able to create permutations on the spot, create a function that generates permutations on the spot. Let's actually walk through that together. So function all permutations. I'm going to go through this actually pretty quickly. Array results equals 0. Let's say this, and permutation equals this. So basically, array is going to be the elements within the elements that we haven't considered yet. If array.length is greater than 0, then for equals 0 plus we want to remove one element at index I from the array. So the element is going to be array at I, const new array. It's going to be array.slice 0 I concat I plus 1 array.length. So this is just creating a new array with that one value removed. That's all it's doing. And then we want to call all permutations of new array result, and then what is it? Concatenate the permutation with the current element, and then we return result. So I believe this is going to generate all the permutations of an array. Once again, if you're really familiar with permutations, then this is something that hopefully you'll be able to bang out. Hopefully I didn't make any silly mistakes there. We'll find out soon enough. But this is a super generic thing, right? Given an array, generate all the permutations. And we can use that here in our problem. So basically, now here, we have this, for each permutation of cards, for const permutation of all permutations, cards, for const op of operations. Let's make a little helper function up here, or helper array. This is a bunch of operations, let's say A and B. This is A plus B, A minus B. If you guys want me to slow down, or if there's we know if anyone has any questions along the way, because around kind of we have this operation. So for each permutation and for each operation, operate on the first two terms. So const new cards is going to be so let's get the first two terms, A and B. So we're going to assume that cards is never going to be empty. We're only originally given a length of 4, and this recursion problem is going to break that array down in terms of length. And if we know it's not a length of 1, then it has to be 2 or more. So let's grab A and B as the first two terms, and then have the rest equals the cards. New cards is going to be the operation formed on the first two numbers, and then the rest. And yeah, so basically we can now recurse if judge point 24 new cards, return true. Otherwise, return false. So let me see if I did that right. 0 of 71 test case passed. So I think I got a silly mistake somewhere. This permutation is not used. Let me see. I have to run to a meeting. Thank you, Tommy. Sure. Yeah, and then I do have the Codementor platform. Feel free to see what I'm up to over there. Yeah, so this permutation actually is not used, so I should have used permutation here. And I think hopefully that's it. No. Okay, so all permutations, let me verify that the permutations is working. Array length is greater than 0. Array result. Oh, yeah. I never push result.push permutation. I'm still getting a Stack Overflow here. Okay. Let me verify. Let me just check with this for my solution really quick. Operations are the same. Judge point 24. Cards length equals 1. Return cards is that. Const permutation of all permutations. Operation of ops. New cards. Let's just see the simplified test cases really quick. Yeah, live coding. Okay. Let me just grab this as permutation. No, that's right. Okay. Well, contingency plan. Let me just, I think I made a silly mistake here. Let me just paste what I have over here. I'll review it again. But okay. So submit. This says 70 out of 71 test cases passed. There actually is an issue with this leak code problem. So it's very dangerous to assume that it's not your code, it's their code. But this site claims that there is not a solution for 338, or it claims that there is a solution for 338. It expects true, and we get false. But like I've verified this too, that there is not. Here's a solver. There are no solutions for this. So I think that's a bogus test case. I have reported that to LeakCode. But yeah, so I think hopefully we at least followed along conceptually with what's going on here. So this 24 game is leveraging recursion, it's leveraging permutations, and it's really just the amalgamation of those two things. So we're generating every permutation. We have these operations. Judge point 24, we're doing this recursively. If there's only one card, we found a solution if that number is 24. And then for each operation, for each permutation, we do the operation on the first two numbers, and we return true if and only if the recursive call returns true. So I know this is much less convincing since I had that bug that I actually couldn't find while live, and yeah, it's a little frustrating for me. But hopefully the sentiment there, right? This is the combination of a few of these concepts that we've learned so far. Is resonating. Does anyone have any questions over this 24 game concept, 24 game problem, and how those concepts roll up together? How many people do we have? Okay. No questions. All right. Well, I guess I'll tell a little bit more about myself too. So once again, my name's Matt. I go by Coach Matt. I have my own platform. I do provide asynchronous coaching where you can attempt algorithms on my site, and I provide asynchronous video feedback. So that's something that you can check out on my site. I do have these algorithms that you can try yourself. And I have concepts. So if you go into something like combinatorics, permutation, right? You can even look at a concept and practice algorithms that leverage that concept and find them that way. So this anagrams problem, figuring out if every word is an anagram. Maybe I'll go through that one really quickly too if we don't have any questions. Let me know if we have any questions. But anagrams, we discussed previously. Anagrams is it's a permutations problem. So yeah, we want to figure out basically if every word here is an anagram. We talked about the sorting thing. So what we can do is basically we can map each word to a new word where all of the letters are sorted. And then if all of the words look the same after each letter has been sorted, then they are all permutations of each other. So let's say const sort word equals word, just word split on each character, sort, and then join back into a string. Const sorted words equals, let's say const words equals text.split on the space. Sorted words equals sort words dot map sort word. So sort all of the words, and then what you can do is just make sure that they are all the same. So say for const element of sorted words if sorted words at 0 is not equal to sorted, not equal to element, return false, return true. There's going to be one case actually where this fails. In its case, so peculiarity of the definition of an anagram is that a word is not an anagram of itself. So brag is not an anagram of brag. Then basically the sorted words. So what you want to do also is you want to make sure that all of the original words are unique. So a fancy way to do that, you could just do new set words dot size equals it's not equal to 1. A set is going to automatically deduplicate every element. So if this is not equal to 1, return false, and then new words dot size. Sorry, chat. Base case. So this is not being solved recursively. This is just being solved iteratively. Victor, did you have a question about the base case for the 24, the 24 game problem? What's the issue here? Expected false to equal true. New set words. So let's just make a little hopper function. Are all unique. Oh, I want to make sure that all of these words are unique. I'm ahead of myself. So size should be words.length. So if it's not that, then we return false. But yeah, I think today too, for me, has been a demonstration of how difficult it can be to talk and code at the same time. And I'll make some course corrections in my my plans for these seminars in the future. But I hope you all found that valuable. We really only have 5 or 6 minutes left, and I want to respect everyone's time. But if anyone has any questions, came up with the same conclusion. Cool. Yeah, ChatGPT does a really good job of solving algorithms and things like that. One of the things that I'm looking to add to my platform in the next few days is big O complexity. So ChatGPT usually does a very good job of predicting the runtime and space complexity of an algorithm. So I think that's something that really is great to roll into a platform like this. There's a little bit more curation, or there's a little bit more fine tuning that needs to be done to get it to work really well. But that's something that I'm going to be adding to the platform as well. You have to be careful with ChatGPT because it will really confidently BS things. So when it gets things wrong, sometimes it's very, very confident in its solution, and it can do a very good job of convincing you of that solution. So, don't cut and paste ChatGPT code into production. Never do that. But it's a great tool. Yeah. So once again, I want to remind everyone that I do offer asynchronous coaching. You can attempt these algorithms. I go with a concept first approach. I do provide asynchronous video feedback over solutions. I have a YouTube channel as well here that you can find. Let me, too many tabs. Okay, let me drop this link. This is where you can find me. Yeah, it's my YouTube channel. I have a lot of shorts where I go over problems like this, and you can see many of these are actually this asynchronous video feedback that I've been talking about. So if you really want to streamline your job hunt, then let's work together. I'll wait till the end of the hour to see if anyone else has any questions. Thank you, Tony. Yeah, it's been a humbling experience for me, right? I was expecting to just nail the 24 problem. But hopefully I did convince you guys that the 24 game is not as scary as it might look. Yeah, and combinations and permutations show up a lot. I am human, yes. Thank you, Brian. Yeah, this is my first seminar, first session of this size. So the next one will be, will be a trajectory in terms of quality moving forward. But I was still pretty happy with how that went. It's a lot of stuff to cover. Does anyone have any questions? Does anyone feel like we went too fast? Right. Someone asked a moment ago about recursion. Oh, base case, Victor. Okay, and then you said no questions. So, okay. All right. Well, I think that's a wrap. You all know where to find me. I'll drop my beacons link one more time. Everything's there. And yeah, good luck. Good luck out there.
Thanks, Matt.
Thank you.